So welcome to week 3 now of our course, and the theme for the week is ethereal problems and solutions. We'll get to the quotes of the week in just a second or two, but here are the main topics we'll be looking at. We'll be starting off with Einstein's starting point, the two postulates that he enunciated in his special theory of relativity, the June 1905 paper. And essentially what he said is, we're going to just take these two things for granted. They actually were two principles that were well established in physics, but that seemed to be somewhat in contradiction with each other. And what Einstein did is sort of had an intellectual breakthrough, because he saw that actually, even though they seemed to be in contradiction with each other, that if you took both of them to be true and then worked out some of the implications, it gave you some very interesting results. So he was just basing this on these two postulates, so we'll figure out what those postulates actually are. I'll just give you a heads up. One of them is the so-called principle of relativity, and the second one is what he called the principle of light constancy. And because that second principle deals with light and whatever light constancy means, we need to figure out more this week about how light waves work, how waves in general work, some of the key principles of light waves and the phenomena of light waves, so that we can understand the background to what Einstein is working with here. So we'll spend a little time exploring some light waves, more or less in a qualitative sense, not a quantitative sense. We won't do a full physical review, say, of how you describe light waves mathematically and so on and so forth. And then we'll talk about something called the ether. You see, ethereal problems and solutions. That's where it comes from. And there was a real problem with the ether. It was cutting-edge physics at the time. A number of very good and great physicists had been working on it. Whatever it happens to be, it's really the idea of the medium for light waves. So sometimes it's called the luminiferous ether, a light-bearing ether. It's we assume that waves must travel through something. Water waves travel through water, sound waves travel through air or whatever gas is involved, and therefore light waves must have a medium which they travel through, that the vibrations, the light vibrations, the electromagnetic vibrations that make up light, there must be some medium involved, and so that was known as the ether. And yet there were some key problems with it that Einstein was really worried about and bothered him greatly. And not only that, there were certain experiments that bothered everybody greatly, actually. And the classic one is known as the Michelson-Morley experiment. So we're actually going to spend a fair amount of time looking at this in a mathematical sense. Not deep mathematics. It'll mainly be algebra that we're using here, but this will be our first foray where we get a little more quantitative than we have been up to this point. But don't worry, we'll take our principle of festina lente, make haste slowly, so we won't try to rush through it, but make sure we're laying that solid foundation as we construct our mental models of what this special theory of relativity is all about and the implications thereof. So the Michelson-Morley experiment will directly relate to what the ether is like and give a certain result. And then another well-known experimental result called stellar aberration also relates to the ether, and we'll find out that these two are actually in contradiction with each other. So you had two very well-known experimental results, and as they related to the ether, one said one thing, the other said the other thing, and it really puzzled the physicists of the day. So we're talking about, this was in the 1880s, essentially. Stellar aberration actually went all the way back into the early 1700s, around 1725 or so it was first observed. So the question was, what do you do with something like this? How do you solve a problem like the ether? It seemed like they needed the ether. Otherwise, what is waving in terms of a light wave? And the properties of the ether, the Michelson-Morley experiment was saying one thing, and stellar aberration was saying another thing, and there are other experiments too, sort of on one side or the other. And it was a real problem in the 1890s and up to 1905. And so then we'll look at some of the solutions to this. How do you solve a problem like the ether? For those of you who maybe remember the musical The Sound of Music, sort of comes from How Do You Solve a Problem Like Maria. So now that I've said that, you can probably, for those of you who remember the musical, can't get that out of your head, so I apologize for that. But in this case, it's How Do You Solve a Problem like the either? Well, there were certain solutions. Some of them somewhat ad hoc solutions, just sort of pasted in there and see if we can get our theory to work with it. Einstein's solution was much more elegant and simple, and so we'll certainly want to find out more about that. So that's where we're going this week. And let's go back to the quotes of the week. Have them on your handout. First one is, there's no doubt that the special theory of relativity, if we look at its development in retrospect, again, this is by Einstein, was ripe for discovery in 1905. And so we will see some of that as we talk about some of these things, that other people working in this area, that it definitely was a well-known problem. They had somewhat solved it, but not in a very satisfactory way. And so Einstein came along and took a very different approach and came up with a similar solution, actually, to what others were getting, but in a more satisfying way. But even having said that, it still took several years, a number of years, before people really accepted Einstein's approach to the problem versus some of the other approaches there. In fact, Einstein's approach was almost too simple. It seemed too simplistic, that he was just assuming these two postulates and then taking off from there, when some of the other theories that were getting similar results were much deeper, much more sophisticated in terms of their physical and mathematical methods, and so on and so forth with that. So, but certainly he said that if he hadn't done what he did in 1905, somebody else probably would have done it in the next few years. It was in the air, as it were. As an aside, actually, for his general theory of relativity, not the topic of this course, but 10 years later, that probably would not have been done as early as it was if it hadn't been for Einstein working on that. Second quote, I lived in solitude in the country and noticed how the monotony of a quiet life stimulates the creative mind. I put that in here just, not that we should all maybe go live in the country in monotony or live wherever in monotony, but in our technologically oriented society where we're always hooked in and connected and so on and so forth, sometimes we need to unplug, as it were. Turn off the email, turn off the internet, turn off the texting, turn off the phone, the iPod, whatever it happens to be, and use that time to do some thinking, because that's what topics like this really require. They require some deep reflection on various matters, and that's what Einstein in particular was very good at in terms of his powers of concentration and stimulate that creativity and innovative thinking and deeper understanding of things. So if you can use that as inspiration, Einstein's quote there, inspiration for doing that, sometimes you'll probably be better off, at least in terms of understanding whatever you're trying to understand. Then he also said, when I am judging a theory, I ask myself whether, if I were God, I would have arranged the world that way. And then the second quote, very famous quote, subtle is the Lord, but malicious he is not. And I ask you just to consider what that might mean, even without understanding Einstein's own context of how he came up with that, what that might mean. Clearly, the whole topic of Einstein and religion is a huge one. There have been books written on his ideas in this area, quotes all over the internet again on these topics. Famous one besides the subtle is the Lord one. Another famous one is that science without religion is lame, while religion without science is blind. And sometimes when you pull these quotes out of context, it's you can get a misunderstanding of what Einstein's beliefs in the area were. He really believed in more of you could almost say a cosmic God or a cosmic religion, certainly not a personal God. And you have to say also in this respect, Einstein was definitely not a theologian. It's not that his ideas were naive in a sense, but that he hadn't, the sophistication of his ideas was not necessarily as deep as it might have been if he'd spent the same amount of time thinking about these matters as he did with his physics and his science. So whether it's Einstein or anybody else, you have to take those things into consideration when they're sort of pronouncing on fields outside their own. They might have very great wisdom in that area and very great insight, but we can't just assume because they're an expert and sort of a person everybody looks up to in one area, even a genius, doesn't mean that goes over into another area. So when he talks about when I'm judging a theory, I ask myself whether if I were God, I would arrange the world that way. He really believed in the beauty and grandeur of physical reality. And his religious belief, in a sense, if you could call it that, was that we humans could actually gain insight into that through our reason and through our rationality and through mathematics as well. And that's what he is referring to when he also says things like, subtle is the Lord, but malicious he is not. That the way that the universe is constructed, the marvelous structure of reality, we actually can penetrate into the insights of that and the grandeur and beauty, as he put it in other places as well. So just some quotes of the week to ponder there if you want. And then, again, this week we'll be looking at Einstein's starting point, the two postulates, and then especially light waves and the problem of the ether. Spend some time with the Michelson-Morley experiment and stellar aberration, and then sort of see the solution, Einstein's solutions, as well as some of the other solutions to this problem, like the ether. And then next week after that, we'll really start to get into the weird and strange results that come out of Einstein's two postulates when you accept both of them to be true.